All right. Hello, everyone. How are you doing? Eyal here. I have my glasses on so I can actually see what I'm doing. And also, I have with me Thea Peterson. Hello, Thea.
Hi, Al.
Uh, Thea is a very talented developer and musician who studied classical music, but is also a developer who has done quite a lot, both in the web space and recently also starting to do stuff in the plugin space. And yeah, we're going to do something cool that is hopefully going to be useful for some people. I know some people have talked to me multiple times about doing this, and I probably need to be clear about what we're doing. But I'm going to do something that is, if you're on the audio programmer Discord or some of the audio development communities, this is something that's been talked about a lot, how to do a MIDI processing plugin. So we're going to talk a little bit about that, and we're going to write a little library that's going to do a few specific things. So how are you doing today, Thea?
I'm doing good. So we're writing a MIDI processing engine, right?
Yes, this is what we're going to do. More specifically,
MIDI mapper.
I was like a weird AI generated music. I hope it's not too loud, too soft. I'm trying to balance it. I hope the volumes here are okay. Let's see, maybe. Do you hear me correctly? Do you hear me okay?
I can hear you fine.
Right. So, okay. So what we're gonna do is we're gonna. I need to find less distracting music to put here. Let's see. I wish I could just play Spotify music.
I know. It's such a pain.
Maybe we'll just have no music. Who cares about this music?
Who cares?
Only if the environment gets a little noisy.
Right.
Okay. So here's what I'm going to do. What we're going to do is we're going to, first of all, start by making a template for a plugin. I already have a template that I'm using online, and we're going to use that as a starting point. I'll explain what does the template do and how we're starting this. Then we're going to very quickly set up a plugin that does nothing, or maybe does something like, I don't know, logging the MIDI message or something simple like that. And then we'll talk about how to do something useful with this. So one of the problems that Thea and I have been talking about is very commonly you want to do something that takes MIDI notes and produces other notes. So most basic way to do this is a transpose. You want to make a transpose function that does octave shift or just transposes you to another key, and you want something that takes the MIDI in and moves it to some other key. Sometimes you want to add notes, right? You want to do something that where you play one note and then it produces a chord, like you're playing, but what you're going to hear is or something, so that you can very quickly experiment with different chords. Maybe you want non-linear mappings, which creates these like custom scales on your keyboard or quantizes to a scale. There's all these different things that you do with MIDI mappers, and I thought it would be cool to kind of, I don't know, centralize this and write something that handles the main problems when doing it like this.
So you take in a single note, and then the output could be a new notes, single note, or multiple notes. Is that correct?
Yes, exactly. So that is that essentially the interface is going to do exactly that. It's going to take the input note, handle that, and we're going to talk more about this later. I want to first talk about the fundamentals of just making a MIDI plugin, MIDI processing plugin. We'll do the little, let's call it, framework of this, and then we would make this do something useful, hopefully. Good.
We will.
Okay. So let's do that. Let's bring my screen up top. Here we go. Okay. Feel free to send questions in the comments. This is streaming on multiple platforms: LinkedIn, YouTube, Facebook, etc., Instagram. if you sing this, I can see your messages, I can see your comments, I can bring them up on screen so other people in other networks can see them as well. Yeah. All right. So what I'm going to do first is I'm going to go to GitHub. Extract this, go to GitHub, and I have to stop seeing my bookmarks here. All right, here we go. Great. So what I'm going to have here, there's already in my public repositories, there's a repository that I'm using that's called Juice CMake repo prototype, and it's a template repository that does a lot of like setting up for you, and it's just going to be much simpler to just start with this instead of configuring the build system and all that stuff from scratch. So I am going to use this template to create a new repository. I'm going to call this MIDI Mapper. Let's call this basic library for MIDI mapping plugins. Here we go. We're going to create this, generating. There we go. Great. So let me go to CLion, clone it. Has been cloned. I'm on the beta of CLion, so it's going to throw out some random non-important errors, but I don't care. And the first thing it does when it loads is it's going to do stuff like fetch juice, configure juice, like it does all this stuff as a part of the configuration process. This all gets done in the CMake file. Some of the stuff the CMake file is doing we probably don't need, so we're going to very quickly remove things from here. But first of all, it's going to generate a bunch of targets. So one of the targets that it has is this MIDI effects templates. We're probably going to use that. But there's stuff like minimal plugin template, new plugin templates. Let's take a look at the MIDI effects template so we can just see what it does. It's called MIDI effects template. And what this does is it inherits from this thing called processor base that has a bunch of like boilerplate. And after the boilerplate, it just does stuff like log the MIDI. So we're probably going to use that. And I'm going to remove all the other targets in here because we don't really care about those. So you can see there's a bunch of like stuff in the template. I'm going to just remove dummy synth. I'm going to remove, what does dummy synth do? Is that a synth? Synthesizer? No, it doesn't do anything. Okay. Let's remove dummy synth. Let's remove standalone filter. Let's remove this, remove this, remove this, remove this. So we don't need all that crap. Just deleting them. Now I'm going to go to the CMake file, remove everything, all the ed subdirectories except for MIDI effects template. So we're just going to have one plugin. Same thing is, I have all these standalone apps. I might keep the console app because I might use it for testing. So I'll remove all these apps except for the console app. Same thing. Well, I'm going to go to CMake and make sure it only adds console app templates. There are a bunch of unit test stuff here. I'm just going to remove them because I might do unit tests that are more related to this particular thing. I don't need the tests that show up as an example. And then let's see. We can totally remove the iOS stuff, I think, for now. Yeah, let's remove all the iOS stuff. What else do we not need here? Statically on Windows, that's good. Find packet juice, blah, 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 blah. Build examples. Okay, there's an option here which we'll use some other way, but it's fine for now. Okay, let's see what we got. I'm going to reload the CMake project. And I should only have the MIDI effects template with standalone VST, AU, and VST3. And the console app. So I'm just going to commit this and say removed all unneeded projects from the template. Okay, that's good. It's a bit clean. There's a whole bunch of modules here. I just need this module. It's called shared plugin helpers. Let's remove these two as well. I don't need shared process. Those are stuff to do with all kinds of examples in the repo, even though we are going to write our own module in this one. So this is going to come in very handy. Let's see if we're still compiling, and I can still compile this. Let's take a look. Oh, you got this. There's a warning here that is a juice warning. I wonder if they fixed that already. Maybe I can just update juice and they fixed it, because it's a warning that only happens, I think, on the latest Xcode or something similar. But it's a warning inside of the juice code. Let's take a look. Did you solve it? Let's see. Is there a new juice version? Because I can just update. Let's go to GitHub. Search for juice. See what the latest releases are. No, they're still on 8.0.10, so there's no new release. And I don't know if I want to update to like develop branch or something. So hopefully they would fix this warning soon. So I hate having warnings in my code. It drives me crazy. So what I'm going to do, just to avoid this warning, just for now, I am going to suppress this warning, but I'll bring it back once Juice fixes this, because this is annoying. So I should have the solution for this somewhere. Let's see, some other project that I worked on, because it was annoying for me before as well. Juice team, if you see this, you can solve your bug.
What are you doing?
I'm just I'm looking at some I'm looking at this off screen, but I'm looking at the place where I solved this, trying to get the exact thing that I used to solve this. It's some CMake code with this problem solved. Let me see, where is that? Let's see. I think I just think of the Did I not solve it there? Forgot what I did. Blah, 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 blah. Not sure. All right. We can probably ignore this for now because hopefully it's not going to show up in next builds, right? So I'm going to show up in the first initial build. So I'm gonna relax my OCD a little bit and not handle this error, this warning immediately. Okay, so back to what we're doing. We are. Oh, I just removed these. Let's make a comment on this. Removed unused modules. Okay, that's good. Okay. So let's start to have a setup where we can test this. The MIDI plugin template, you can write it as standalone, but what's going to be more useful is we're going to run this as a VST3 and we need some host to test this in. So I'm just going to build this, and fortunately there is a free host that we can use to test this. It's made by us. It's called Plugin Buddy by Modalix. One of the reasons why we made this is exactly for this. We can run MIDI plugins in a chain without a bigger, more complicated DAW. So what I'm going to do is in my configuration, I am going to select that the executable for this is going to be Plugin Buddy. And let's run this. It's going to load a Plugin Buddy. Let's load an init preset, and let's do a rescan of the plugins. Give it a second. I have a lot of Waves plugins, so they might take a little while to scan, even though Plugin Buddy is pretty fast in scanning. Sometimes the plugin itself is doing some things. Okay, scanned, and now I should see the name of, I think it's called something like your company or something stupid like that, right? Let's see, what does it say here in the name that I use for the plugin? Plugins, MIDI effects, my company. So we need to change that probably. But it should show up here, my company, MIDI effects templates. So the plugin now shows up. There it is. It has beautiful UI. Everything that shows up on the top here is stuff that Plugin Buddy has been added. And what this does is this template should log what the MIDI is doing. So if you can see my screen here, you can see it says something like incoming note on blah, 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 velocity, blah, blah, blah. And if I'm going to play my keyboard, or let's connect my keyboard here. Let's have it go through my Nord stage. And now you'll see it's actually giving like velocity information, different sample positions. Only from the UI, it's going to bring in 0 because it doesn't know exactly when it occurred. But from the interface, hopefully everyone can see this, is that it logs in these beautiful events. I can even do stuff like aftertouch, right? Here's the channel pressure, and it handles it beautifully. Fantastic. So what we did now is we created a nice setup for us to test this. When we do something useful with the MIDI, I can actually put in a synthesizer right after this, so we can see what the MIDI processing is going to sound like. That's also a useful feature of Plugin Buddy. Yeah, so we got this happening. Let's close, and we're good. Or not, maybe I'll change it from my company to something else. We don't have to. Let's keep it the way it is for now. My company is a great name. It's a great, the best company name. How are you doing there, Thea? Are you doing good?
I'm just trying to, minimize the noise on my end.
All good.
You know what I mean?
All good. So let's explain what this is doing, what this template is doing, and then we can do something more, more useful. So right now what this template is doing is it iterates over all the MIDI messages. Oh, here you go. It also does a transpose. You see, I did this kind of like intentionally. It does a transpose, or transposes all of them to be 60, right? Which is kind of stupid, but would still be something that we can hear. Let's see if it does that. Let's connect to a synth. I'm gonna turn off my internal sounds in my keyboard. And what should happen is all notes should become a C because of the way the template works. Let's put a synth. Let's pull the internal Plugin Buddy synth. This is it. Here you go. So now look at what happens. I'm playing notes everywhere, but what the processor is doing is that it modifies them to C. Right? So one note samba. Okay, so, or it's a one note synth. So that's great. We know that it works. I can close the UI here. The synth is partly good enough. And now we know that processing actually does what it should.
Okay, let me have a look.
Yeah, so let's have a look at this code. This code is inside of the function called process block. So for those who don't know, the way not the way plugins work, not just audio plugins, but generally plugins, when you have a plugin for like OBS or plugin for a program, what happens is we connect to this program, the DAW eventually, and the DAW calls us to do stuff. And this is the meaning of this process block function. What happens is, when you have audio or MIDI in the track, then the DAW is going to call different plugins and say process, right? Do something with the audio. If you're a distortion plugin, it's going to call you with the audio buffer, and it's going to say, hey, you can apply your distortion or apply your reverb or whatever it is that you want to do. And MIDI is kind of the same thing in VST3 at least. In VST3, MIDI comes in along with the audio. It's kind of connected, because if you think of a synthesizer, you're going to get the MIDI notes. Right, let me go and move myself to here or something, or even here. Here. Okay. So what happens is we're going if you're a synthesizer, the processor is going to call you and say, process some notes, but it also would ask you to put in these notes in the synthesizer and fill the audio buffer so that eventually you would hear what comes out of your synthesizer, right? So what happens is we get a block, a buffer, and the buffer has audio samples in it that we can fill ourselves. We don't have to process them necessarily, but also it has all the MIDI messages that were in your MIDI clip in the DAW or you played live or anything. And then it's our shot as the synth or the processor to do something useful with that and make beautiful sounds.
Are we gonna add like callback type, like std function, std vector, vector bin there? Because we're gonna expand on it later.
Yes. This template is just, first of all, it's here because this is the template that was created in the template repo. It's not very useful. It's not very useful to turn all notes into a C unless you're very sadistic about your audience.
Mm-hmm.
However, I think it's good because it's going to help us to figure out the possible. So it's going to help us not worry too much about the framework for now.
Okay.
Or about how a plugin is structured or something, even though we are going to talk about that a little bit. But the thing is, I want to have a class that's very simple. There's not much in here. There's the only thing that does is it creates a generic editor. And then we need to start doing some stuff. Okay, but the point is, one of the things that happened here is that there's this thing called temporary buffer, this temp buffer. The reason why we needed a temp buffer is because when we get the MIDI buffer from Juice, if we wanted to do stuff like, modify the samples, Juice actually doesn't let us modify the samples in place. It's not an action that's prohibited. What it does is that it gives us like a view of this array, of this, not really an array, but this data structure called MIDI buffer. But what Juice kind of expects is that if we wanted to replace it, we kind of have to remove all the messages from the target and then put them back. So instead of here, I just did a swap. But what we can also probably do is do something like after we finish copying our messages to the temp buffer, because we still have to read from this array while we're writing to it. Then when we finish, we can go ahead and, for example, go over all the messages in the temp buffer. Sorry, so before that, we're going to clear the original buffer. And then we're going to go over all the messages in the temp buffer and add an event, get message, M sample position, and then just add those notes. This would pretty much do the same thing. So
Can you
this
make
would
the editor a little bit bigger?
oh sorry, I completely forgot that I have my here you go. Oh, or even let's go back to let's go back here. This is better.
Yep.
So what I did was, thank you for telling me that. What I did was what I said was this is probably a better way to do what I just did. So there's a temp buffer, and when we finish with the temp buffer, we copy all the messages from the temp buffer. And this is actually a very common pattern in MIDI processing. It's so common that let's make a function for this. Let's say something like something with a good name, something like void copy. Let's call it replace contents with const juice MIDI buffer source juice MIDI buffer dest, and this is going to do exactly that. So the dest is going to be cleared. We're going to go over the source and copy things from the dest to the source. I'm going to make this a no except just because it's a little better and could offer, in theory, potential optimizations. And let's do static here because this only shows up on a CPP. What does it say? Oh, never used. Okay, good, because we just did this. Here, let's replace contents with temp buffer, MIDI messages, and I can remove this inline thing. The other thing I'm doing here, which probably also should be a function, we're probably going to use that often, is the logging part. We might use that pretty often, like just log in the MIDI. So instead of this being inlined, let us write a function that says something like static void log MIDI, and it's going to take a MIDI buffer, MIDI messages or something. MIDI, what's wrong with that? Oh, what did I mess up? I forgot like a semicolon there or something. What did I do? MIDI buffer, and why is my code all screwed up? Oh, because I didn't close the function. Okay, so so I'm just going to use this. I don't need this incoming. Let's just type in that. Let's just put in the get description, and then the sample position. That's good. So this is going to be useful stuff because we are very often going to need to just be able at any place in our call stack just say, hey, log MIDI messages. And this is the transpose stuff, which we probably don't even need. So we can actually we can remove that. So now we have a function that log MIDI over here. So we now don't even have to do the for loop. The for loop is kind of separate. So now this should make it clear to see what this thing is doing. This is the flow of the original example, except for the transpose part, which I removed. Also, I think for some reason my clang format.
So are we using temp buffer as the destination buffer, like during iteration, or?
Yeah. I just have a CLown problem here, and you just see that it has clang format. Oh, here we go. Let's replace it with, it doesn't use my beautiful clang format, which should be clang. Is it here? Let's go to my this is just because of the beta of CLown, it has some weird bugs with clang format. So let's do where clang format, and let it use this. Just me crazy that my here it is. Now it's gonna look like I want. Perfect. Okay. I hate the fact I had to do manual formatting of code. I like everything to be tool enforced if I can. Okay, so what did you ask me about what we're doing?
So you were iterating through the source buffer that you just Replace contents with that one, and adding processed events into the separate temp buffer. Is that what you're doing?
Yes. So what we're doing now is we're starting by clearing the temp buffer. We're iterating over every message in the source buffer, in the incoming messages. We copy them into the temp buffer. It sounds kind of stupid because we're not doing anything useful, but it would be useful once we change the MIDI. And that we replace the contents of MIDI messages with temp buffer. So we just copy it back in. We need the temporary buffer, again, because the juice MIDI buffer does not let us modify MIDI in place. But also, when we're going to do more complicated things pretty soon, like make one note generate 3 MIDI notes, we would need a way to insert things into this structure while iterating over it.
Because it's not safe.
Yes, because if this MIDI buffer technically is not a vector, but let's say it has been a vector or anything, or almost any container. You can't, like, let's imagine, let's go to my console app. That's one of the why I always love to have console apps in my project. So imagine if I had something like auto v equals std vector of int, and it would have 1, 2, 3, 4, 5 or something, right? This is working. Do I need this? Okay, vector of int with 1, 2, 3, 4, 5. So I can go over every element of this array, of this vector. Sorry, go to v, and then I do something std cout. Right, I can do this and have a for loop and read things from the array. But if I do something like, if e is 2, then go to the vector and push back 50. This is not going to be good. Does anybody know why? I know not a lot of people are seeing this probably, but from whoever sees this, if you know why this is really wrong, and by the way, you can see that my loop is very corrupted, right? If I remove this, it's going to be good, 1, 2, 3, 4, 5. But when I print this actually gives out very bad values. Do you know why? Do you know why this is really screwed up? Thea? Are you here? I think you're muted. Thea, are you still here?
Yeah, I'm here. Sorry.
Okay.
Because it's range-based for loop, it expands. Sorry. Is it the vector? It can cause like the vector to relocate memory. Is that right? Reallocate.
Yes, exactly. So, yeah. So when you call this range-based loop, what this is going to do is it's going to call something like vector or v.begin, and begin is going to give you the pointer to the beginning, right? And then when we keep going over the loop, it's going to do very similar to what an index-based loop does. But what it also is going to do is, or what I mean is that if we change this, if I do a pushback here, the vector actually gets copied somewhere else, and it means that the previous pointer is the pointer that we got at the beginning of the loop is actually not going to be valid. So you can see by the numbers here, I'm going to get absolutely bizarre numbers, right? After I do this pushback screws up my entire loop. It can actually crash, by the way. I think it's kind of random that it didn't crash, because that memory is basically that old memory that we started with is going to be irrelevant memory at that point. So it's not legal to do something like this. I mean, it is legal. It's going to compile, but it's not something that you want to do. What you want to do usually, if you work with something like this, is like you want to first read, then write separately, right? So you don't want to read. You can write to the elements in place, but you don't want to change the array. You don't want to reorganize the array or sort it or something midway through this loop. This is not going to work well. So back to where we are. So what we did to avoid the situation is we had this temp buffer, which we're clearing at the beginning of every block. We write everything into it. Everything is organized in the way we think it should be organized. And then it writes back. And let's do something useful so that we can understand why that, how that can be useful. Because usually we don't just pass the messages through. Usually we're gonna do something useful with the message. For example, we can say that if the message is get, let's do something like O2 message equals m get message, because this m is a container that has the message and the sample position, and it actually only constructs the message when we ask for it. Now that we've asked for it, we can say something like if message is note on or off, and message dot if it's note on or off, then if message get note number is bigger than 60, only then put the message in. You can just call this message because I've already constructed this object. But otherwise, if it's not a note, we can just put it in. That's probably something we can do, right? So we can write this in a better way, but I'm going to get rid of this code in 2 seconds. So this would be, and let's now, instead of logging the MIDI of notes coming in, which is okay, but let's log the MIDI of notes coming out. That's also why this function is so useful. Let's run this. Okay, so I'm playing these notes, and you can see that they're not coming out. Look at this. When I get here, C sharp, which is right above this, right, they are coming out. So that's how we create a filter in this situation. We filter every note. Do I still get a log in the beginning? Oh, sorry, I'm logging the wrong thing. I need to be logging the temp buffer before I make the copy. Okay, so this is my filter. You see, nothing happens, and right when I get above the C, this everything was copied. And we can sometimes what you want is to do more useful things. Like think of something like, let's say you want to do something that is like more for a live situation, for like a live performance situation. What you might do is for every number, like I don't know, let's say you want to do a keyboard split. So you can say that if the message is above 60, then what you want to do is you want to, maybe I'm going to take the message anyway, just do it, copy the message at the end without this branch, without this as well. But if it's above 50, I might do something like, let's use message here. And if it's not 60, I can do something like message dot set channel and go to channel 5, because this, what I want to do is I want to have all the high notes go to some other synth, right? Let's say I have some live setup with multiple synth. We're not going to hear anything different now, but we could see that all these notes are channel 1, but all the high notes are channel 5. I hope you can see this in the log, right? I can probably do this now. Good. So you can see that the log says that all the low notes, whatever, C2 or something. Sorry, I have this annoying window here that I need to get rid of. So all the different low notes came to channel 1, and all the high notes came to channel 5. So this is one useful thing that you want to do. Just change channels. Let's go. Sorry.
Do we have to like clamp the range, like to valid? Like I think it's a 0 to 127. Is that right? Like a MIDI range. The output note numbers. We don't have to do that yet.
Sorry, can you repeat that?
Like, do we need to clamp output like note numbers to the valid like MIDI range?
Yes, I didn't have to do it here because I didn't change the note range. But if we do a transposition, we probably do want to do that because we don't want to send out notes in invalid range. Like, who knows what's going to happen as a result of that.
I'm already thinking about that. that plugin. Sorry. Okay.
No, you're totally correct. So we definitely have, and we're, I want to explain the modification status with the MIDI because we're gonna work a lot with that. This is why we needed this extra buffer. Okay, so let's commit this first thing. I don't need any of this, any of these things. I'm just going to commit just initial cleanup and extracted common operations like logging and copying buffers to a function. Okay. These are all going to move to the library, by the way. All this stuff are going to be very useful, like logging and replace contents with and all that stuff. Okay. Because you'll see it's going to, once we write more functions, we're going to need just placing log MIDI anyway. We don't want to write manual loops. Great. So now let's start to do something useful. Let's say that we want to write something that is a transposer. It's going to take notes in one pitch. It's going to make it another pitch. Sounds simple, I hope. So for what to do this would be a good time to add a parameter. Or because what would be cool is we want to let the user with the UI decide how much to transpose. So we're going to very quickly create a parameter here. So the parameter class is going to be called juice audio parameter int, but this is a long name and I'm going to type it twice in a second. So I am going to do something like using param int equals this because I want a shorter name, because I'm going to do something that looks like this. Param int equals new param int. This is something that is horrible to do in regular C++, but we have to do this in Juice. Let's call this transpose. This has to be a raw pointer and directly call new, even though this is probably one of the worst practices. And the reason why you do this is because Juice historically asks for something that you call new on, and then it deletes it for you. It's really weird. It's a weird setup. I really hope they change it one day, that we don't have to just call new, and we can just have a member on the stack, but it's not currently possible in Juice. So this is the way we have to do this. So we're going to do this and then create something like, let's give it a name. The name is going to be like this is actually the ID of the parameter, transpose. This is a version hint, something that Juice needs, which we can discuss sometime later. This is going to be the name, so transpose. Next one is minimum, so minimum is, let's do minus 12. It's going to be minus 12 is an octave. Go up to plus 12, and the default is going to be 0, so no transpose. So this is our transpose parameter. Then in the constructor of the plugin, we just need to do add parameter transpose. So that's how we make a transpose parameter. And if we're going to look at the standalone of MIDI effects, even before I'm going to write it in the DAW, build. Ooh, I have a problem here. What did I do? What did I do? Let's see what I may have mixed up. Oh, I did 12 and 12. This should be minus 12 and 12. This is probably the error that I'm getting. So, running this. And let's look at this beautiful UI. Look at this. Look at this beautiful automatically generated UI. Let's get a slider with our parameter. This is actually going to be reported to the DAW. So the DAW also knows about this parameter. And this should help us, like test things. We can test it with automation or something. Okay, so first of all, we made this transpose parameter. And now we're going to apply some transpose. So what we're going to do is we got the message. If the message, we're just going to naively write something, and then we're going to write it better after we write the naive version. So if the message is note on or off, then message.set note number, message.get note number, plus transpose get. And this is our transpose function. Transpose get is going to give us an integer with the number that the user chooses, and this is going to increase it. So let's test the VST3 version, and let's see if I got this correctly. Okay, let's look at our this is our plugin with the transpose button. So I'm going to start by playing notes, right? C, D, E, right? And let's move the transpose up. I'm still going to play C, D, E. So what happens? Everything goes 1 minor third up. I click a C, but you see that it's actually transposed to E flat, 1 minor third up. Let's click G. It's actually going to send out a B flat. Okay, so this works. This actually transposes some basic transposition. But this is not perfect, and let's explain why. First of all, one of the problems I did was that I naively assumed that, no, I can just take notes on and off, and I can move them to some number. I didn't do any limitations on this number. I think it's very likely, it's very possible this would crash if I play too high of a note. I don't know how high I can play with this keyboard, but let's move the keyboard up with my octave up button. Oops. Where's my plus octave here?
What's going on?
No, I just need to do because now my plus, how do I make the plus octave on this work? I need to let's just do it in here. Go up an octave, and then I can't even get to the gets so high, I think. Who knows what this does? So first of all, we probably need to apply some clamping on the actual values. But another but I want to let you see another bug that is very common. Here's something the user could do. Something the users could do in this, right? They could run the transposer and very beautifully, do beautiful transpose things, right? But see what happens. Let's say that I'm going to click the notes, have a transpose set to some value. Now I'm going to change transpose and let go. I've let go of the notes. See what happens? It's still playing. Not so good, right? That's not a good experience we want, because what this does is that means that we kind of assumed that the user is very responsible. We assume that the user would first play all the notes, then change the transpose, and then do all the notes off correctly, and then change the transpose. So, but the user might not do that. The user might have their finger on the mouse or MIDI slider or something, and they might change that transpose value. And then they would need to, they might have their note off happen in a different transpose value, and we still have to tell the synth, the target synth, that the note off is the old one that was sent to it, not the new one, right? Because we don't want these stuck notes. It's not good. So how do we do that? That means we have to keep track of these notes and send the note off to the one associated with the original note on. Here's how we're going to do this. First of all, I'm going to extract all this temp buffer stuff. What we're going to do is I'm going to extract all this into a separate class. So it's going to look like something like, let's call it MIDI transposer. It's now no longer a plugin. Oops, sorry. This would have the temp buffer. And let's have a function called process. And the process function is going to take const juice MIDI buffer MIDI messages and int transpose. So it doesn't need to know about the parameter type. It can just know that it's an int. Let me change the name for this. Let's give it a better name. Let's call it output. output. This is a better name for process, and I can even do I can even return it. It's going to be just a fun interface. So I'm just going to do MIDI buffer and then just return the output as a result of this. This would be good because this would let us do something like O2 output, O2 transposed, and we need to have a member of this thing. So have a member called I need this exposed to the header. So let's put this in the header for now. I need a MIDI transposer. So the transposed MIDI is going to be transposer.process, which takes the source and the parameter. That's what it does, and then immediately I can just use it, right? That's why it's very useful to return a reference to this buffer. Like it's let us write this. If you'll have multiple processors here, we can write very expressive code. Okay, let's see if this still works with the bug that was shown before, but still works. Okay. Let's look at the transposer. Here it is. Still works, and still with the bug of the stack notes. Perfect.
So do we need to like store the transposed note for like each like held note?
Exactly. So, exactly. So we need to start managing state here, realistically. So here's, and this is where slowly the MIDI mapper is going to come into place, because now we're still hard coding transpose. We're not generalizing, but this is going to be a common theme here. Here's what we're going to do. Let's see how I'm going to do this. I'm going to do, so one of the, this could actually be something like, yeah, let's do I'm going to do something like struct note state. The note state is going to have something like bool on or false, and then float velocity. The velocity is important because some people do like to like we might want to connect. We can think if we want to take the velocity of the note off from the note on, or do we want to use, we can just use the note off. So we can just use this as, we can just use this bool for now. It's probably better than using bool directly because we're about to store it in a container and it might behave weirdly, depends on, because something like std vector with a bool, it's kind of weird specialization that does something else. Anyway, so what I'm going to do is I'm going to do an array here, because this can be a fixed array. This doesn't even need to be a vector. I can do an array of note state 128. Instead of 128, let's do something like const expression and get num MIDI notes, or let's call it get num MIDI notes. Turn 128. And this is called note state, or held notes or something. And this would help us keep track of what happens. So here's what we're going to do. Instead of doing is it note on or off, oh sorry, I'm confused. What we also need to do is we have to put an int here and say
like original note and set it to -1, like -1, and
yeah, exactly. So we probably don't even need the bool here. So we probably could do something like int. This implementation is going to change very quickly when we switch to mapping multiple notes. But we can do something like int mapped note or something, and it's going to be -1. This is going to be better. We might have more information here later. But so what I'm going to do is we're going to do something a little bit different. Oh, by the way, instead of using, I don't want to use std array here. This is something else fun that I'm going to do. Instead, I want to use oopsie. Instead, what we're going to do is we're going to see, we're going to use a public repository that I have called CPP data structures. This has a lot of useful things that we're going to be using. And one of the things that I like about this data structures is that there are some really important ones that are there. One of them is the fact that there's versions there of array and vector that, among other improvements that I made, are also using integers instead of size t. And this is just an ergonomics thing that I like. I think it's very important. And so we're going to go here and in my CMake folder where I'm doing find juice, I'm going to do the same thing, or let's just do that with, yes, this is a better one. I have a thing called find catch too. So let's add a find module that says find EA data structures. Need to change data structures to CMake. That's better. And let's find the thing. So it's ELM music, CPP data structures. So it's going to be, I don't even need this. I just need to do Yalmir music, data structures. Is it called main? I think main. And I'm going to, just when I did find package here for juice, I'm going to do find package EA data structures required. Let's see if here it is. CPM can just fetch it, bring it into the build. And now when I go to the plugin, I can also ask it to link with EA data structures. What that means is I can go here into the code. So, and then here, instead of using std array, I can go and include EA data structures, and then I can use EA array instead. Perfect, got it. So now when we do this, we can go and work with pure integers, and we don't have to worry so much about converting to size t and unsigned ints, which were an unfortunate problem with the old or the original STL library in C++. So now let's talk about the logic that we're going to do. Here's what's going to happen. We're going to handle differently for note on and note off. By the way, I want to say hi to Tio Tiger, who's on Instagram watching us. Thank you for tuning in. Okay, so if the message is note on, we're going to do something else. And if the message is note off, we're going to do a different thing. So if the message is note on, we're going to take the message. First of all, we're not even going to pass all the messages directly, because actually we could pass the message directly just for now until we have multiple notes. So this might work anyway. So if so we're gonna let's do something like O2 transpose note. Let's do this. Original note equals note number. And then the transpose note is going to be this. So we are going to set this on the message just like we did before during note on, but we're also going to store it. So we're going to go to output, sorry, not output, held notes with original notes, and it's going to be equal to the transpose note. Sorry, dot map note. So we're just going to assign this to this. And whether you keep yourself, why do it even need this dot map note? It's because pretty soon this is not going to be just an int. It's going to have more things in it when we deal with multiple map nodes. But now when we store it, when a note off comes in, here's what we're going to do. We're going to go to we're going to get the, I can even, I'm still going to get the original note here. But then I need to go to held notes original notes. And basically I need to message dot, let's do something like to state equals held note or original note map note. Okay, so first of all, we're going to dispatch that note number because it's very possible, we don't know what the transpose was, but it's very possible that it has been different. So we're going to send the states on the message. So the note off is going to be dispatched correctly. Also, we're going to go to the state and set it to -1. So that next time we would know. Even though now it doesn't matter really, because I think now it should always work, but in the future we would actually need this empty state, I believe. Yeah, we actually don't really need this because I think technically we're always supposed to come back from here. So what I should also do, I should also check if state is bigger than bigger or equals than 0. Only then do this. And otherwise we'll just send the message as is. Okay, looks good, right? Because note off could just come in out of nothing, so we have to handle that. Good. Let's see what happened now. Let's run it. Ooh, what did I forget? Oh, this is because I need to. This is something I have to fix on my template, by the way. But I need to make my C++ version 20 set CXX. How do you call this? Blacking out on the syntax here. But I need to, my library requires C++ 20. So I need to go to where is that? Here it is. Yeah, and while we're here, let's change the name of this project to MIDI Mapper or something, because not this. I think this should work because we're requiring C++ 20. Building. Still getting the juice warning, but no other warning is there, hopefully. I really need to suppress that warning. Good. Let's run it. Let's run it through a plugin buddy. Let's see if we fix the bug. So now we have the transpose slider right over here. Now I'm going to play. I'm going to move the transpose. Play again, and now you see no stuck notes. Pretty cool, right?
Transpose value changes while a note is held, like the note off now still targets the correct note.
Yes, and we have no stuck notes, and this works just fine. Also, what would be good is if when we calculate this transpose note, is we should probably protect it from going to invalid values. So what we can do is, right when we do this, we can do transpose note equals juice j limit. J limit takes lower 0, 127, I think it should be, right? And then transpose note. So this is also going to help us from going to invalid values. We're going to do this before we do this like calculation on the transposition. Okay, so this works. We can probably commit this because I think this is, first of all, this is already a working state of this thing. Added initial MIDI transposer class. Okay, that's good. So this works, but the problem with this is that this only handles the case of transposing. It does not handle the case where we want one note to become multiple notes. It also doesn't handle the case where we want one note to become 0 notes, like if you want to do a filter, right? Just like we did in the beginning when we just wanted to filter a range of notes. So we want to take care of that. So what we're going to do is we're going to start to write this little, or improve this like note state abstraction. Instead of having it be an int, we can make it be a container, right? We can make this be something like a std vector of int. Also, we're going to be smarter about this. That's one reason why we made this a struct and not just like pure int. And we're going to reserve a bunch of notes here. Like, for example, we're going to reserve something like 128 notes so that let's use the same constant expression thing we did. And in fact, instead of using std vector, I can also use ea vector, just so that I'll have the beautiful integer semantics and some other things we're probably going to use. There's actually some other more optimized containers in the library. We can use something like static vector. That is, it's basically something that has get number, so we don't need to reserve this because it's actually based on an array. That is going to prevent any kind of situation of doing this. So I think a vector is actually fine here, but we'll see about that. So this is the note state, and what we're going to do is we're going to manage that state slightly more in a more efficient way. So now this thing called held notes, I'm actually going to make this a class on its own because it's going to have a bit of like interface stuff. So it's going to be something like struct held notes. Internally, it's going to do this hold this array. But then we can do I think of the best way to do this. It should be map, and the map is going to be something like int source int dest. That would be the basic function. What this is going to do is going to go to held notes source, and it's not even a map notes, map notes. Held notes dot map notes dot why is this a std vector? It should be an ea vector. Map notes dot add destination. I can actually, now whether because an EA vector and not a std vector, we can do something like add if not there, so that multiple notes are not added. That's also a useful feature of this container. Not sure if we need it right now, but it's one of the many useful things that we have here. There are like one-liner shortcuts to things in the SDL. There's stuff like erase if, which is different than the remove if we get on the standard library. It's this doesn't require multiple stages. Similar things. there's something I could do. I could do something like map notes.sort. Instead of doing stud sort of this. It's so all kinds of like shortcuts to things in the standard library. Anyway, so we're going to add this. We're going to add this, and I think that's it, right? We're going to map this, and then we are going to the same is going to be. Let's call it do something like held notes. Yeah, so I need something like that returns this vector. Gets the held notes for the source. It's going to return held notes source map notes. And then we can give it some option that says, some function that says clear int source. So we have this held notes source dot map notes dot clear. Probably don't have to give it access directly to map notes here. I can add some member functions, but this is the general idea. So what it means is when we're doing this, right, we need a function that says we need to do held notes dot map. Oh, I need to change the type of this from whatever this was before to held notes. Then held notes, instead of access directory, I'm just going to do map of original note transpose notes. This is all we need to store this. When we finish, or when we get the note off, now instead of doing this little thing, we're going to do a for loop. And this is where it gets interesting. So what it means is first of all, I need to now handle this case more elegantly. Instead of doing it like that, I need to also have an explicit handling of the situation where it's just not a note, which could be in MIDI, could be just a pitch bend message. So now that we got a note off, now we have to dispatch the multiple notes. And let's see how we're going to do this. We are going to we got the original note number. That's good. Now we're going to for O2 held notes or notes in held notes dot get held notes for the original note. So this is going to give us a container. For each of these, we're going to have to create a new message, right? So for each of these, we are going to take the message, set the note number to be, this is just one note. So set the note number to be the note number. And oh, sorry, I need a transpose note first. Where's my yeah, oh, that's good. So blah, 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 I need to do that, and that for each of those I'm going to I'm completely blacked out today. To do this map, yeah. So this map, we actually need to know which nodes we're going to. We don't just do this map. This. We need a function that lets us do this multiple times. I get confused here a little bit. Kind of thinking too much about the future. So what we need to do in this situation is something actually different. What we need in this situation is we need to have something that knows which notes go to which map. We need a function that does this. And I'm going to let's see if we can think of like an interface to do this. We need something where for now, I'm going to do something that says let's do something like this. Says map notes int source held notes dest. This is what it's going to look like. So what it means is the input, this will pretty soon go to the user and not be a part of this class, but this is like a simulation of the callback that we're going to create. So currently what this is going to do is still going to do the transpose thing. So what I'm going to do is I'm going to add the transpose value in here or something, but very soon I'm going to get rid of transpose because we don't need to be this explicit. So what it's going to do is going to do source dot, sorry, it's going to be dest dot map source to source plus transpose. But pretty soon we're not going to do this, right? We're going to do something more interesting. But this is what, so instead of just calling this directly, I don't want to calculate transpose note here. So maybe I should also have all the logic of like limiting here. You know what? I can actually have the limit right here in the map function because it's going to be useful. So dest equals j limit. So we can just do the limit right here before pushing it inside of our vector. No, this is not a good idea. No, let's not do it. Let's not do it here. Let's do it over. Let's do it where we're sending this. Yeah, I think it's better. So let's do it right here. O2 transpose note equals source plus transpose. Let's do the limitation here. Still call the map function. That's good. And then I need to iterate over the mapping to send the notes on. So what I'm going to do then is I'm going to, instead of sending this stuff on the message directly, now I'm going to do, oh, and also I need to get this back. So let's do something else. This is going to start to move along with my interface. Map notes equals a vector of int. I'm going to make a shortcut of this. It's going to be map notes. Oh, and when I do map, I'm going to return this. So let's do const map notes. Good. It said no except here because it's always better to do that. Very good. So held note source, and then return the get held notes. Good. So when I do this map, I need to return this, right? Does that make sense? No, I don't need to return this. No. No, I don't need to do this. I already have it. So I can give this as void. My mistake. Void. When I map this, and now I should have a for loop over held notes get held notes for this original note. And now I need to generate correct information for this. So for each one, I am going to take the message, set the note number to the note, And by the way, this could be 0. So if it would be 0, there would just be no messages added. Like this would be empty basically, and this is totally correct. Great. So we're doing this. Same thing we're going to do with the notes off.
I might have seen it wrong, but is map notes, is it like writing into held notes right now? Let me
What is?
map notes, the function.
Map is a write function. Map happens during the note on.
So is it writing directly into held notes right now?
Yes. It's going and it's changing something in this vector, basically.
Okay.
Which we pre-reserve to make sure that we're not allocating memory. So there's not so it's totally safe to do, totally safe to write into a vector like this. And let's see if we get this to work, right? There might be some duplication here that we can actually modify, but this is the idea. This is basically how this works. We can even do something like I can have a function that says apply. I don't know. This looks pretty good. Let's see what this does. Like this should still do the same thing, is my point. Okay, this is my transposer. Bring the view here. Haha. Okay. I actually have a bug here. The bug was see? It still remembers something I did in the past, and what I forgot to do is I forgot to clear, because after I do this thing on the note off, I should just do finish with that, and then held notes dot clear original note. Because once I didn't clear, those notes kept on coming. So let's see if this is okay. Bring my transposer. Here it is. Okay, this still works. And this does the thing with the transpose. But the thing is, the multiple note stuff is actually not very useful with transpose. Am I correct? Yeah? Right? All this multiple note stuff I did, right? All this vector I added, all this stuff I added really feels stupid with something like transpose, right? With a transposer, it's kind of redundant to do all this vector stuff.
Uh-huh. I was just wondering, are we reusing the same message object when so every iteration like just overwrites it right now? Is it?
Yes, and that is just because this is probably not what it should be doing, but this is good enough for the transpose plugin.
Okay, got it.
But it's probably not going to be good enough for a harmonizer plugin. So let's start with thinking about well, I mean, it is going to be fun probably for basic harmonizer plugins. We'll see. Let's start with an example. Let's say that what we want is we want to dispatch multiple messages, right? So what we can do is, for example, let's say that what we want to do is if the value is 0, let's write a more complicated function. Let's do so that if so it's going to do the transpose note stuff, but it's also if the transpose is different than 0, because with 0 we don't care about like we don't want to dispatch the same note twice, but let's keep the original note in there so we have an interval, and this is where it's going to be interesting. So if the transpose is not 0, we're going to do dest map source. So we're just going to write the source back to itself. Does it make sense? Yeah?
Yes.
Okay. So now look at the magic of this. Now we made our transposer. So with a transpose value of 0, it should do the same thing. Right? It should be just keeping the notes that I'm playing, play them as is. But if I'm going to have a transposer be 4, ooh, I have a bug there. I have a bug. Why do I have a bug? Why did it not do what it should be doing? Because why did it not work? Did I not generate did I not have multiple nodes here? I think I need to debug this. This is interesting. This is not what should have happened.
So you have to like double check, like.
Oh wait, I'm still doing double stuff in here because I'm stupid. I don't need to do all this stuff here. I'm not even calling my function. I can remove all this stuff. I mean, I do need this original nodes, but that's it. I had this beautiful function and I'm not calling it. I need to do just map nodes with the original nodes, held nodes, transpose. Okay. Now I'm actually going to call the function that I wrote. Okay, works with the 0. Beautiful. Look at this. Let's make it a 4. So it's right. Beautiful thing that can do any kind of augmented key. Right. Let's make it do a 5th. Right. Emerson is very happy right now. Nice, right? So now our mechanic already works with something that creates a harmony, right? We can create all kinds of harmonies. We can write different functions to use harmonies, stuff like that. The interface is still not generic, but this works. So let's commit this, and let's just like enhanced engine to support 0 to many nodes for each mapping. Okay, how do you feel so far about this? Thea?
Yeah, so I was just wondering, like, I need like some clarification. So I know that we can't reuse the same MIDI message like when outputting multiple map notes. So like, don't we need like fresh note on off message for each note?
And we do. So whenever I'm here, like this is our note on code, right? I'm going to clean this up in a bit so it's going to look nice, but there's going to be a function here that says note on, note off. But this is the note on branch. And we map notes, right? And then for each one of the map notes, we are copying a new message. This is a new message that goes into the output buffer. Does that make sense?
So like right now it looks like all the notes are collapsing into like the last one, or
it looks like, sorry?
It all like they all collapse into the last one. It's not like
no, they don't. So when this message is added, this message is a copy, right? It's basically a new message. If I do this call 5 times, it's going to create 5 separate notes, because this is not a reference to the message. This is a copy of the message. So we can copy many messages. Like every time I do this creates a new. I'm reusing the source object just for simplicity. Like I can also do something like like to new message equals juice MIDI message note on, and it's going to take the m.get channel message.get channel and the note number, which is this transpose note, and then the original velocity, like message.get velocity. Like we can also do that and then use this new message, right? This works the same way.
Okay, gotcha.
Right.
Yeah.
So I just simplified it because we're only changing this, even though might not be the best. Maybe people would want to use what we're using now, for example, to create a velocity mapper, right? That's legit, totally legit. So like, if you want to use something like that for velocity, you would have to do something else. But so this is only for something that deals with notes. And we can make it do more, but this is the basic idea. Okay?
Mm-hmm.
Good. Okay, so let's start to make this thing generic now. Let's see what we can do to make this more generic. What I'm going to do is I'm going to start writing a new Juice module and move all the shared stuff that I'm doing into a Juice module so that any project can use this. And we're going to start generalizing the code itself. So I'm going to make a new Juice module. It's going to be called EA MIDI Mapper. This is my beautiful module. The Juice module format means that you have to write an H and CBP file, EA MIDI Mapper. And they have to have the same exact name as the module. Hopefully this makes sense. And then there's a bit of a header that you have to copy. I'm just using the template for this, which is just stuff like ID, vendor, whatever. So this is going to be called EA MIDI Mapper. The license for this is not going to be GPL. It's going to be probably something like I don't know, MIT. This is the name. The reason why we're doing like this, by the way, with a module, one reason is this is going to work with the producer, but this is also going to work well with the rest of the Juice build system and kind of inherit macros the Juice are using and other useful stuff. So here's the way I deal with modules in general. A module is basically just one H that has all the headers and a CP that has all the CBP files. That's how Juice does its own code as well. So what we're going to do, I'm going to start putting code in here. So I'm going to write two libraries. One is going to be called common, which is just a convention that I like to use. And the other is going to be called, let's call it, I don't know, MIDI or something. Common is just going to have an H file. It's going to be called common. This one is going to include Juice, audio, utils, and it might have other like common things that we're going to need everywhere. MIDI is going to have, let's call this, let's put a class in here. Let's call this, let's call this a mapper, MIDI mapper. Great. So I am going to go to my thing, just copy the thing from that. Oh, and I also wanted to connect with EA data structures, which we have seen before, structures, which is my arrays and vectors and all that. And those should also belong in the common. Oh, to connect all of this, the CMake should have this call, juice add modules. And the project should connect with this. Instead of connecting with EA data structures, it's going to connect with a MIDI mapper. So that should connect all of them. They should have juice EA data structures. And let's just move our class now to the module. So the class, and probably all our functions too. The functions would also be very useful. We probably need to have them as their own thing. So let's have, while we have this, these are like the classic stuff for a module. Let's call it helpers or something, MIDI helpers. And then we have to include those CPP files. So it's going to be MIDI helpers.cpp. This is something that Juice uses, which is a very good idea that they've implemented, which is called Unity builds. What it means is mapper. What it means is that there's one CPP file that includes all the other CPP files, which means they all build as one thing, and that makes compiling be very, very quick, very, very fast. So let's do this. Now let's have this as in a namespace. And this is where it's going to be fun writing this, because one of the things you see, there's a bunch of like juice MIDI buffer everywhere. And this is annoying, but we don't want to enforce like using namespace juice on the user code. This is intrusive. The user might have their own MIDI buffers, whatever, but we can definitely import things into our namespace. So our namespace, which is going to be something like EA MIDI, could do using juice MIDI buffer, and it could be using juice MIDI message. Like, I don't mind to import these into my namespace because I know there's not going to be any collision. So that's good. So now what I can do is I can include the common, and I can just remove all this juice stuff. Oh, sorry. I need to write it first in the namespace. So namespace EA MIDI. And now Ceylon immediately knows that I don't need to specify these types because these are my types. I can also decide I don't want to just specify juice string. I don't want juice string everywhere. It's the string. Stuff like that. Very useful to just simplify the way I'm writing without being intrusive, without making the user have all kinds of like using stuff that might have problems with. This is a very small scope for me to import things, and this can also be no accept probably.
So now you're doing this, like all CPP files get like merged, like the Unity builds like basically like smash all CPP files together. Is that
exactly? Which and that is actually a very useful thing to do, because one, it makes the compiler compile much faster, because the compiler is basically going to reuse everything that it, like for example, if you're if helpers.cpp includes juice and mapper.cpp includes juice, both of these CPP files separately would have to compile juice. But if they're a part of the same translation unit, the compiler has already compiled juice for the first one. It's not going to compile juice again, the juice headers for the second one. They're already there. They're going to be. So if you're going to stack CPP files that all have similar dependencies, they're going to compile dramatically faster. There are a lot of, by the way, articles online about why Unity builds is so great and why it's fast. I love it. A lot of libraries are using that. Like if you look at the VST3 SDK, it's also using Unity builds. Really great stuff. So where were we? Okay, so I just wrote these like two generic functions. Those are just going to be nice. And then when I go to the template, so this would just be called something like in the plugin, we can just do include EA MIDI Mapper. We also need to have these headers in the header so that they're exposed to the user. We don't have to have all of them exposed, but we probably want to in this case. We can have internal headers that are not exposed to the user. That's not a problem. And this is good. The user now can include this. Now let's move this whole big chunk away from here. Now let's simplify things. And first of all, So just be a vector int because we're in the EA namespace. So that's good. Array. Beautiful. What else? Juice MIDI buffer is in our namespace. We don't have to rewrite all this stuff. Much nicer. Nice, 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 nice. And instead of calling this MIDI transposer, I'm just going to call this a transposer. Very soon I'll change the name because it's going to be a MIDI transposer. I don't need to specify MIDI multiple times. So now the user can do EA MIDI transposer. And they want to call the functions. It's going to be EA MIDI log MIDI, whatever. I can just call it log or something. Just call it log. MIDI log is better. I guess. Because log could sometimes collide with another name, but for now I think it's fine. And then MIDI replace contents with. So these are our two functions. Good. The processor has almost nothing but an instantiation of this transposer object. Let's see if we compile. It should be the same thing. Oh, and we also want to move probably some of the stuff to a CPP file. Let's do that so that we're a bit cleaner. This is okay, and then node states. Main thing to move to the CPP file is this. Oh, I need to include the comment here. This is one way why I have had comment here, because all these like using stuff should be common to this entire module. I don't have to re-declare them every time. Good. We can keep these implementations here just for now. I think we're good. No errors. Let's see if we're compiling. All these horrible juice warnings, juice fix your warnings. I've reported this on the forum. I think they said they were, maybe they fixed it in like the develop branch or something. But anyway, this is good. Let's now there's
it compiles faster. Why is it? Because it's like the compiler says smaller units instead of like a one giant like translation unit. Is that?
I'll explain. So let me first commit this. Let's say moved all common functions and classes into a new juice style module. Okay, so it compiles faster because, you know, like I said, if you think of like how the compiler usually works, you know, like, you know, let's say I have a console app and it has something called main.cpp, right? Main.cpp includes juice score. So the compiler has to go to juice score, and there's going to be a billion headers in here, right? It's a big library. It's going to go to all of them. These are just macros, and then it includes a million other includes, right? This is the entire juice core. Juice core is a massive thing. It's a massive beast. It has, where are all of them? It has a million other headers that it includes. Here they are. Lots of headers. So every time we compile main.cpp, the compiler has to build some map of all these symbols, right? So like, because we're calling functions from juice, right? If we do juice, I don't know, array, right, or something, or juice critical section, right? If we instantiate each of these objects, the compiler has to find it. The compiler has to go to these headers, find a map of all these symbols. It has to parse it, has to compile the syntax, if there are implementations there, inline implementations, the compiler would have to compile those. Let's say we call a function that's inline, or create a template. The compiler would have to recursively go into all these headers and compile it. Let's say we make another CPP now. It's going to be called function.cpp. The compiler would have to do the exact same thing for that CPP file, because it doesn't know that it's the same exact one as the one in main. The compiler is not allowed in the initial compiler stage to poke at other compilation units. Right? The compiler can say, well, I know that you have main and you also have another CPP. I'm going to first poke in them and kind of look at the includes and see what you did there, and then remove all the shared stuff and combine them together. The compiler is just not allowed to make that decision on their own.
So like it does like the heavy work like once and caches the result?
If you use the Unity builds.
Yes.
If you use Unity builds, what you do is you tell the compiler, like you explicitly tell the compiler when we have this you tell, look, this CPP is not on its own. It's actually, this CPP is actually this CPP and this one. So what the compiler is going to do, it's going to go to mappers.cpp. It's going to follow the includes, right? Go to the common includes, going to see juice for the first time, right? So it does juice, blah, blah, blah. It's going to, does what it did, compile whatever it needs to compile. But then it's going to go to the second CPP file, and this is still in the same unit, right? It's not, for the compiler, it's not a separate file. It's because it's using an include. So it's going to go, it's going to go through this include, going to go through this include. It's going to find juice. But it actually, even before when it goes to common.h, it's going to reach this thing that says pragma once, and it's going to stop. It's not even going to go there because it already did it. So it's significantly faster. Now, when you think of what the compiler has to do after it does that, because the compiler does way more than just parsing. The compiler actually does all these optimization steps and other kind of things. This is also better because the compiler can have a way more condensed view of all the different symbols. Like the compiler could actually see, for example, it can see mapper.cpp and it can see helpers.cpp. And if they're calling each other, for example, if helpers.cpp is calling, it doesn't do anything now, but if it had called replace notes from before, which it probably should, I need to add this in a second, but if it does that, then this is the compiler could optimize them and could inline all these calls because it knows them. It's a part of the same thing. Otherwise, we would have to wait for the linker to do this. And the linker might have less information because the linker already has the result of the compiler. It might not be exposed to everything the compiler did. Here, the compiler gets exposed to everything that's connected during the compilation stage.
Okay.
Make sense?
Yes. So it doesn't have to like reparse like the juice, like giant header graph.
It has to parse it, but only once.
Only one time, yes.
Instead of once for every CPP.
Mm-hmm. Got it. Okay.
Okay.
So like only recompiles your like small module files on change after that.
Sorry, what did you say?
It only like recompiles your tiny modules, like the module files on change. Like it doesn't.
Yes, it's not going to compile, and that's true for juice as well. Like if you don't change juice, it's only going to compile once when you have to change the build system or something, but not when you change your project. Okay, so we got this happening. We have this transposer, but like we said, this transposer is probably not good enough because what we want is we want to have the user of these classes write their own function version of this map notes thingy. Right? That's really what we want. What we want is to have a more generic version of this because we want to have something with that users can build their own mappers. They can build the transposers, they can build harmonizers, they build chords with different whatever. They can build multiple things, no problem. Right? So I'm going to build this new thing. It's going to be called a mapper. Transposer is going to use a mapper, and we'll get to that in a second. it's gonna have these. I'm basically gonna move almost everything from this to this. So maybe I'll do the opposite. Maybe I'll change this thing. I'll refactor this to be a mapper, and then I'll make another thing called transposer. Right? So we need a way to have a custom map notes function. And here's how we're going to do this. Instead of doing map notes directly, the first, like the simplest way to do this, and we're going to start with the simplest way before we may, but we might do the fancy way. The simplest way would be to do something like this: struct, let's call it mapper. Let's call it notes mapper. Something like that, note mapper. And this thing is going to have a virtual destructor because it's going to have a virtual function in it. And the virtual function would look like this for now. It's going to be something like void map. It's going to take, I'm going to start with doing it with an int, but it's probably not going to be an int because we might do stuff like velocity here. So it's actually much better, I think, if I do. Yeah, let's start ignoring velocity for now before we modify this, and then it's gonna have the held notes as a destination. But this function is going to be a virtual function, and it's going to be a pure virtual function, so that whoever is using this would have to implement it. Good. So we have the note mapper. Now, when we process this with the mapper, instead of passing it a transpose directly, I don't want to do that here in this process function, I am going to pass it a note mapper. And we can actually pass a different one in every process call. This is going to come in very handy. You'll see why in a second. Every process call, you can pass a different mapper, and it's totally legit. So now, this function that says map notes, as we wrote before, this is now going to be specific to our transposer. So I'm going to remove this. The transposer is going to inherit from note mapper, and it's going to implement this thing. This is going to have a transpose value in it. Equals, start with 0 or something. And the implementation, we already wrote it, right? Because we know what the transpose is. So it's going to do this exact thing. And I actually think, did I clear this before for every new node? I didn't, but I probably should. Like, it's actually possible that I should probably process. We'll talk about this in a second too, of what happens with a double note on the same one. This is also something we might need to protect from, but that can be on the system level. So this is our transposer, right? It has its transpose member function. It overrides this map function when we have a note on. It does this transposition, it does this limiting, blah blah blah, and it maps the multiple destinations. So it still does this harmonic thing that we did before. Now, when I process here, so we said we were going to do the note mapper. So instead of doing map notes, we're going to do note mapper dot map held notes. Note mapper itself knows about transpose, so I don't need to care in this class at all about transpose anymore. It's all in the responsibility of the transposer. So here's how this would work. I would make it. I'm going to take this transposer object. Put it in the plugin. Instead of making mapper, I'll put it. Sorry, I assign the mapper, but I also need a transposer, and this is actually going to be the mapper. might think of. I'm gonna find a way to combine them in just a second. Transposer. We're gonna use a nice template in a second that's gonna combine these into one. The mapper is going to process. The mapper doesn't care about the what transpose, but it wants to know what are we going to pass it that can do this kind of transposition, and then the transposer is going to take its parameter from the transpose get, just the parameter equals, right? So this is it, right? This is what the user has to do. And you'll see how cool is this, because now we can pass different ones. But let's see if this compiles first and see if we get this correctly. Okay. What did I forget? Oh, I didn't forget anything. I'm still in 0. Let's move to something else. Works. Great. So here's what happens now. Now we can control the mapper that gets passed in, and it could be a different one in every call. So for example, we could have a dynamic thing. We can have multiple objects, right? Multiple stateful objects that all do that. And we can talk in a second about like more modern ways to do this. We can use templates. We can use other cool things, but this is like a very simple way to express how this would work, right? So when we're calling process, we have all these nice things. So now I can take the transposer. I'll put it in its own file. It's going to be kind of separate. It's called this transposer. It's not really a transposer now because it's also a harmonizer. So we have to give it like a better name. But let's start with include mapper, and this is going to do namespace MIDI. Let's add this to transposer.cpp. Transpose.h, we're going to expose those. Somebody just took a picture. Yeah, did you take a picture?
Yeah, I'm sorry. Yeah.
Okay. And
are we like? Okay, I need a little clarification. So it's like, are we giving each mapper its own state object? Is that what you said? Because you said we can have multiple objects.
Yeah, the user can do whatever they want. And not only that, the user can use multiple ones and change them dynamically. And we're just going to do that. So remember that when we did this, right, we had this little thing that also adds the additional one, right? So one way is we can actually, first of all, we can make this transposer thing be stateful. We can have a Boolean parameter that says add existing node or not, right? That's one option, right? We can enhance that transposer as much as we want. But also we can create totally separate transposers, totally fine. Like for example, let's say that this transposer is going to, I copied this. I don't need this transposer.cpp. Let's write it all in an H just for now until I know what I'm going to be writing there. Okay, so let's make these super. Let's have a transposer and let's have a harmonizer. Let's have separate ones. So this is the transposer without this, basically, and this is the harmonized transposer, right? So what this would do what the previous one did before. They're going to look similar for now, but they would not look similar when we do other things. So this one does have that, the other one does not have that, right? They're kind of separate. Cool? Hello?
Yeah, I got it. So like, you're just making it generic, like, so you can like
so let's
just one implementation of a node mapper, and then later you're gonna plug in like harmonizers, filters, whatever.
Yeah, and we're going to use them. Let's add a new parameter. So I'm going to do something like using param bool juice audio parameter bool, and I'm going to do param bool equals, let's call it harmonize, equals new param bool harmonize 1, harmonize, the default is going to be false.
So does like each mapper like keep its own memory? So like, so different mappings like don't interfere with each other? Is that what you?
Yeah. So so the only thing that keeps the memory is the mapper, but maybe we want to call it their name. This is going to be called something like a mapper processor or something. I don't know. But these things don't keep any state. They don't inherit from mapper, right? They are completely separate. They're very simple that only deal with the map. Map virtual method, map interface, right? So that's all they do. So what it means is that so let's do, I need to also add parameter transpose, add parameter harmonize, and then what I'm going to do is let's do something. Let's write it as a nice function. It's going to be something.
Okay, I think I got it. Like this is the transposer doesn't actually store anything. It's just like kind of describes how to map notes. It's just like a stateless rule, right?
Well, it could be stateful, but it's
But
going
you're
to keep its
making
own
it
state. Like it would have to keep its own state, right? You can, for example, we can write something. We can something that, for we're going to write a stateful one. This is going to be great. So we can write something, for example, that first node does one thing, second node does something else. Third, like we can write a stateful object, and it's totally not a problem. Like,
so we are making it stateful.
We could decide the user of this node mapper object can do all kinds of things, and we're going to see them in a second. So what I'm going to do, I'm just going to write a function here. Let's write this function called it's going to be something like process. Input or something. Can this be const? I forget. I think it could be const. The reason why I'm doing this is, you know what? I think that I also want to do, just to save typing for the user, I might also want to do a process in place here. It might be even better. So let's do something like process in place, and it's going to just take the MIDI. So let's do something that saves the user a bit of typing. This should be, by the way, no except. This should also be no except because these are all called in the process block where we do not want exceptions. So what process in place is going to do, it's going to do exactly the stuff here. So it's going to also need the utilities. So it's going to go to here. It's going to do this thing. It's going to do just process and then replace contents with. So it's going to do something like O2 processed equals process MIDI message mapper. Then it's going to call this function with the processed one. So that's going to make it easier. Can I just do let's make this be the default function. It's going to be better. Let's call this process, and let's do something like get processed. I think it's going to be a slightly better name. So this is called a function from the helpers. I had to include that. Now, this could just be void. This doesn't need to return anything. This is going to be a simpler call site, probably better for a plugin. The reason for get processed is that get process is going to help you chain processes together sometimes when you want to do like parallel processing outside of this thing. But it can be done either way, so I don't need this function. Instead, so first of all, I can just do mapper.process. This is not needed anymore, right? So the user just needs to call this. And then what we can do is we can do something like if harmonize get, do this, else do harmonize transporter, right? Do the thing with the harmonizer. Let's see if that works. Here we go. Oh, I did the other way around. I replaced the branches. If you want to harmonize, you want to use the harmonizer. Makes more sense. Okay, so let's see our plugin. Plugin is not saving state now, by the way. It's kind of annoys me, but I would fix this very soon. Okay. Right, this is fine, good. Now let's harmonize. Ooh, harmonize does not work. Let's see why not. Why is my harmonizer not working? Let's see why. Oh, because I changed the transposer, not the harmonizer. Okay, I just passed it on 0 all the time. And I'm not even processing the harmonized transposer because I'm lazy. Okay, now it's gonna work. No, wait, I'm completely out of this. This is correct. This is the harmonizer. Okay. I don't even know what I'm doing. Okay. If I harmonize, okay. Here's the UI. Right? Works well, dynamic. Very beautiful, right? Who doesn't want to have all these perfect seconds? But I can totally do some Emerson music with this. Great, perfect. Okay, how do we look so far? I think we're starting to get into a pretty good place because now the user is able to write their own mapper. The user can even change multiple of those. So let's make this commit. So started adding a general way to create mappers. It's also a dynamic way. Forget about that. But here we go. So we have the dynamic way to do mappers. Let's see. We talked about a stateful mapper, right, Thea?
Yeah, can you still hear me?
Yes.
Okay, my audio setting got messed up, so I was just kind of frantically fixing it. Sorry.
What got messed up?
My audio setting got messed up.
Oh, okay. Do you still want me to talk to you, or do you want to still fix it?
As long as you can hear me, I'm fine.
All right. So let's do something else. Let's write. Let's call this. Let's call this. It's gonna be. Let's do a stateful transposer. And the stateful transposer is what it's going to do is let's do something like int state. Yeah, state or something. It's good. So I don't even need the transpose one in here. Here's what I'm going to do. or I can just call it transpose, also going to be fine. But this one is after we're going to call map, it's going to do plus plus transpose. If transpose is equal to 12, or let's do 13 because I want to have 12 there. So bigger than 12. If it's bigger than 12, all right, let's do this. I want to make this fun. Let's do bool direction equals true. So if we're direction, probably need enum for this, but whatever. If we're going up, then plus plus transpose. If we're bigger than 12, or if we are at 12, if we are at 12, then direction equals false. Let's do the other direction. Else minus minus transpose. If transpose is equals to minus 12, then direction equals true. So it's going to come back up. True. Yeah, so every time we're going to call this notes, it's going to change direction. It's going to go up, harmonize, go down, and so let's see what happens if we do that. I'm going to go in
It's like almost like a sequencer. I don't know.
yeah, exactly. It's almost like a sequencer. So I don't know how beautiful it's going to be, but we have it. So let's do a MIDI stateful transposer. Now, instead of doing this harmonized parameter bool, let's do int param int. It's going to be something like oh, you know what? Let's do something cooler. Let's use a param choice for this, using param choice equals choose audio parameter choice. This is probably the best parameter for this. So this will create a nicer user experience. So param choice, let's call it mode. It needs like a static string or juice string array. Get modes. Return. Let's call it transpose. Harmonize and state. How am I going to call this? Let's call it sequenced harmonized. Okay, so this would take the get modes, and the default I think is the next one. Yeah, 0. Okay, so this is the mode parameter. And now instead of doing this, let's do a switch here. Switch. How do you call this? Mode get index. Case 0. Case 1. I think it's opposite now. I think this should be the first one. This should be the second one. And case 2 is just like state mapper process MIDI messages. Composer, and then this should probably be an enum, but I'm too lazy to actually do an enum. I don't need this MIDI log for now. It's just in the way. Yes, I think that's it, right? Oh, default, yes, cert false or something. Let's not make sure we can't use anything else here. Okay, loading plugin buddy. Let's see our beautiful plugin. First of all, here's the choice parameter, right? 3 choices. Transpose, harmonize. Why is harmonize broken? What did I do? What did I do to break it? Did I do anything wrong here? What did I do? What did I do that did something different with it? Oh, I forgot to break. So it was processing it twice. There you go. So just a syntax problem on my part. Okay. Bring us back. Good. Harmonize. Good. And sequence harmonize. Now this is going to be ignored. So I'm just holding C. I'm just playing C all the time. And I'm just going to play random notes and see what it's going to do. So right, it's a perfect counterpoint writer.
Yeah, I think we already built the plugin there.
Right? I'm just running it. You see how it keeps moving and making the. Now let's make it even more fun. Let's make it random, right? We can make a random one. So let's do the same thing. Let's do well, there because like because I keep writing this function. Let's write as helper. It says inline void transpose int notes int offset. I'm just gonna do this thing that I'm gonna reuse this thing that checks the transposes this thing and does the J limit. So return this. Good. Accept. So this is just going to be transpose note source transpose.
You kind of turn that into like a tiny sequencer now, because it's got like.
Yes, I'm just first making this all in a one-liner, right? Because this is just a bunch of repeating code. Yeah, I can totally make this sequencer. We can do a whole bunch of stuff here. So let's write random called random transposer. Right, it's going to have a juice random in it, and the map function here. I don't care about this transpose value, but then I can just do auto transpose equals next int from minus, let's do from minus 24 to 24, so 2 octave ranges, something like that. Let's see if that works. So let's go to our plugin, have the random transposer in there. Random. Let's add this mode. It's a new mode. It's called random. And here when we process this, case 3, with the random transposer. Let's see if this works. Okay. Right. Let's go to our random. Ooh, it crashed. Beautiful. Oh, because what I did was I forgot to what did I forget? Break is what I forgot. Because those were it was hitting the default case as well. Loading plugin buddy, beautiful. Okay, so I'm just gonna play C. Always gonna play C. I'm literally hitting the same note all the time. What could be making better music than this? This is the best music, right? It's almost sound like a cat playing piano or something. This works polyphonically, by the way. It's no problem. Beautiful, beautiful. We've become all modern composers instantly, right?
Kind of like,
yes, right.
But then the one that we're gonna make had like it added a fine transforming, like it compared the input node to an axis, and remember it applied a fine transform and then shifted. It had like a really clear mapping logic. The one that I showed you.
Yeah, so we can write custom mapping log. We don't have to write randomizers, right? We can do whatever we want. Like this is just the reason why I wrote this is that like for example, if you think of like an arpeggiator is doing exactly this, but then once in a while you're changing the mapping.
Okay.
But there's like for example, whenever the user puts a new chord, you change the mapping. No problem. You can do that, right? With this thing, right? This has no problem changing the mapping is just like another function call. Like it's not something that happens, we can do this in process block. We can do this anywhere. There's totally no problems here. You can create, something that is a scale quantizer, right? We can create multiple scale quantizers. Yeah, so this would be a good start, I think. I think this is probably already usable. Like you can just clone this and use I think we might need to add some smaller things because now if you're just going to clone this, this would give you a bunch of like definitions and targets that you probably don't want because it's kind of going to force the targets on you. If we want to make this more of like a library, I'm going to need to make almost all the stuff be on the user side. Like the user would have to configure their own macOS target or something. So let's talk about this right now so that it's a bit more useful, I think. So first of all, let's commit this and added more harmonizer modes. Okay. So what we want to do is I think we still need to find package juice. This would probably be good, and find package EA data structures. It's fine. Because I think in this case, if the user would bring juice on its own, I think this would work. It would not re-bring juice. We have to make sure this actually works. So let's do this. But what we do want is there's something called CMake top level. Let's search for that. So CMake top level. Yeah, so we need something like if projects is top level. Oh wait, I think this requires a higher level of CMake. Is that true? Do I really need this? Is that the one? I think that's probably it, right? The recently called project is currently. Yeah, because what we want is we want so that if the project is not top level, then only then we probably need to do all this other stuff, including all of these. So and if yes, so modules we need, but the plugins we probably don't need if we're building this, because the plugins are just like an example. So the plugins are probably yeah. So if we're not in the top level, we're going to test this in a second, how it's going to look like when when we're kind of bringing this along as as an external project. So this should still be okay. So what I'm going to do now is I'm going to experiment with making new projects. And would it still find? Yeah, I think it should still do that. So so here's what we're going to try. This should work. This should work. I think it should work. Oh, I don't need this thing at all. Doesn't do anything. So now what I want is I want somebody who opens like a completely new project, brand new CMake project. They should just be able to do, let me commit this. Edit conditions for when the project is not top level. Okay. It's good. So now the user should be able to do something like in CMake, they can do something like include fetch. Let's see if I can find an example, because I never remember syntax of stuff. Fetch content example. Yeah, so I just grabbed it from the this. So it's kind of like fetch content declare. I think I need this. And then fetch content declare. Let's grab the repo for this. So GitHub MIDI Mapper. So this is the repository. Git tag, I think, can just be main. Let's call this MIDI Mapper. And let's call this fetch content make available MIDI Mapper.
You're doing this so that like other projects can like automatically download and use the MIDI Mapper module? Is that as like a dependency? Why are you doing?
Exactly. That is exactly how it's gonna work. So I want to make sure that I'm not imposing anything other than my requirements for Juice on the user. So I want to make sure that users can use this. Is it not git tag main? Let me just double check my the CMake documentation here. Never remember that stuff. It's called branch or something. Get origin slash. Okay, so I need that. Origin slash main. Here you go. It's bringing it. Oh, what happened? What happened? So this error. Oh, maybe it's maybe it's not origin slash main. Maybe it's something else. What branch was I using? Oh, it's called master. Okay. Master. Okay, good. By not providing fine and juice. Okay, that's good. CMake error. Okay, so that's good. What it just said to me. Great. So what it says to me, it says to the user, you need to put in juice. By not providing fine juice, blah blah blah. Good. So what it means is that's exactly what I want. What I want is I want the user to do exactly what I did here, to find a way to bring in juice. So, for example, I should be able to do this. So just kind of like connects my CMake folder, my this folder that's just mine called CMake. Here you go. And now the user knows how to bring in juice because I've explained to the user how to get juice through this. I can also add like a tag or something that says we're using the juice that was built in with MIDI Mapper. But now the user can bring in their own version of juice. It's fine. It can be locally installed or something like that. But the good thing is, even though I got it, there's no targets here, so you're kind of not exposed to the dummy plugins. But what I could do is I can do target link libraries with I might need to make this a juice app, so I might need to say like juice add juice. Why is it not finding this? Why don't I get autocomplete? Blah 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 blah. Depths, structure source. Go to source of MIDI Mapper.
So the core MIDI mapper is now juice agnostic? Is that what you're doing? So juice is only required when you're integrating into a plugin.
Yes, I hate fetch content. Fetch content now is not very smart and keeps doing like cloning. But yes, this should work. And what I want to do is I want to make sure that this target. I just built a target called untitled. That's now a juice target, because this has to be a juice target, and this should just be able to connect with EA MIDI Mapper. Let's see if this is true. Yeah. So what I did was I created a very minimal project that just creates a juice app. It's not going to play much, but it should be able to build, and it should be able to build a MIDI mapper, and it should be able to link it right into its own project. And now I should be able to go to that project and do something like include EA MIDI Mapper, and I don't know, something like O2 buffer equals juice MIDI buffer. And then let's add some messages, right? Let's add a message called, add event, juice MIDI message note on in channel 150 half velocity and 0. Let's add a few of those. 5, 8. Sorry, let's keep the same channel. Let's do it 173. Good. So we have a buffer with all these messages. Let's create this thing now called EA MIDI. Let's use this. Let's use the regular transposer. Let's have the MIDI mapper. Let's do mapper dot. Let's do something like transposer dot transpose equals, I don't know, 3, and then let's use the harmonic transposer. It's better. And then let's do mapper dot process with buffer and the transposer, and then MIDI log buffer. Let's see what happened. Here you go. So we have the harmonizer, right? We put in, it gave us D, F, E, right? And then we got a, it got a D and an F because it's all minor third, right? D and an F, then E and a G, then C sharp and E4. You see, everything went a third up. So we just tested that it totally works. You can compile. This is, by the way, how we would write unit tests for this, right? This thing can totally be unit tested. We probably need to do this as the next step. But this is the idea. So now, if you look at the CMake list for this, I hate using fetch content, so I'm probably going to change this to use includes CMake/CPM, and then do CPM. How do I call this? Let's just copy paste from my previous syntax to deps MIDI mapper source. Good. This is cleaner. This should also make sure to not to cache, and it should not keep cloning things. So it's going to be much faster. Much faster. Good. So this is better. It's not trying to clone every time from Git when it knows the cache. And let's run this again. Perfect. Look at this beauty. It's amazing. What could be better than this? It works. We can write like a 5-line thing that tests everything that we you know what? Let me copy this entire example into the MIDI mapper itself so we can see how it works from here. So just an int main, it says include EA MIDI mapper and includes this instead. Let's move this file away from the source directory. It's just boring to have a source directory for one file. Reload this. think it's a pretty. This shows that this, that I think this thing is still pretty ergonomic. Like I think it should still be pretty easy to use in a plugin. You can see here in a plugin, all you have to do is like here I had a very complicated setup with multiple transposers. I had 4 different transposers, all do things, including logic. Should be pretty easy to handle. You can just process MIDI messages. Let's run this. Compiling, good, works great. Okay, let's commit. Let's say added console app example of the transposer workflow. And I think we're pretty good. What do you think, Thea? Are we good?
Yeah, so you got like 4 things going. Like the switch statement is choosing which mapping logic is like to apply for each mode. Is that right?
Yes, and this is just an example, right? This MIDI effects processor thing. This is an example plugin. This is not a real plugin. A real plugin would do something better with this, right? But I'm just saying, I just wanted to show something that shows how the library is used. Like this plugin doesn't even store state. Let's just for fun, let's make it save state. I should have a function for this, right? I think it's something like so set state information and get state information. So I need to implement these 2 juice functions, and I think I wrote them in the shared plugin helpers thing. Yeah. Let's see how am I using this because I forget. Save the tree, and then I need to make the tree data append to XML string. Do I have to write a string in here, or do I just like append
Mm-hmm.
something like that? And when we load the preset, we just set state information. We can do something like equals juice char pointer state or something. Or maybe we could just do juice string. Right, I forgot how we're going to construct this. How does juice get constructed from this blacking out? Blah, 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 blah. Or maybe the value tree has something like this tree. We'll use a function to from. Do I need a stream here? Oh, to stream equals use memory input stream from data size false, and then read from stream. helpers load params tree. This tree. I think this should make it save the state. Let's see if this works on the plugin. So let's run the where are my other targets? Where are they gone? CLAN. All right, what are you doing to me? Where are you? Still decided to drive me crazy today. Hate when they do that. That's what I get for using a beta version of CLAN code. MIDI Mapper. Oh, here you go. My targets are back. Now let's see if my state is saved, if my parameters are saved. I'm going to change the value of this parameter. Close, come back. No? No, so it didn't work. Why did it not work? Let's see why. Let's look at my my example again, because I've done this in my example, so I can just copy that instead of trying to be smart. Plugins, minimal plugin template, or sorry, plugin templates. Oh, here it is. Okay. Probably need to make this is in the. I don't know why this is not in the base class.
You were using a like stream-based load path earlier. You weren't using XML like I normally use.
Exactly. I should just. I think I probably should make this an XML instead of just a stream. So, anyway, yeah, this is probably the problem. Blah 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 blah. But anyway, I'm just going to do this in get state, and then in set state, I'm going to do exactly what this does. Just because this part is so boring. I should have made, I'm not sure why I didn't write a function to do all of this exactly. But let's see, coming back, and oh, now it saves. Let's go to sequence harmonize, close it, come back in, and back. Good. Now we have a state saving, added basic state saving and loading for parameters. Good. Here we go.
Yay.
Do you have anything else to add?
No, I think that's pretty much it.
Yeah.
No? Like, basically built the whole like basic engine for the things that we want to build.
Exactly. And I think there's quite a lot of things that can be built on top of this, like arpeggiators, scalers of sorts. Yeah, as long as, you know, we need to talk about, I don't know, MIDI filters. We have to talk, like, I still haven't done like this interface might need to be changed a little bit, because maybe we want to support like velocity. If the velocity is such and such, do something. If not, do something else. But I think we're good. I think it's a good job done for today, right?
That's great. Good job. Well done.
All right. All right. Thank you, everyone, for sticking in. This has been almost 3 hours. I hope this is going to be useful for somebody. There weren't a lot of people on the stream, but hopefully people are going to watch this on YouTube and enjoy our conversation and discussion. So, all right. Have a good night, day, everyone. And
Right.
talk to you soon.
Ciao.